Hi everyone, it's Christian, the P4 working with Dr. Matulowicz these 5 weeks for my APPE, and here's the video on calculations involving topical products. So a few important concepts before I move on. Number one, usually for solid dosage forms like topical products, suppositories, capsules, or powders, you're going to make extra to account for loss. So unless otherwise told, remember to calculate for the 10% extra mass of the topical product. Concept number two, QSAA means of each, meaning that equal portions of each ingredient must be calculated, which I will go through in the 3 calculations examples I have following these important concepts. Number 3, calculations for the wetting agent are based on the weight of the active ingredient in the stock recipe, since it is being used to help incorporate. I'll go more into that later on in the examples, but basically when you're calculating the volume or the mass of the wetting agent, use the volume or the mass of the wetting agent indicated in the stock recipe if it's given. Otherwise, you can just use it straight from the volume of the wetting agent, the mass of the wetting agent used in the prescription. When using calculations for the wetting agent, remember that 20 drops is equivalent to 1 milliliter. Number 4, specific gravity is an important concept in topical calculations, and it's defined as a ratio of the weight of the given substance to the weight of an equal volume of water at a similar temperature. In formula form, it looks like this, where the specific gravity is equal to the weight of the substance divided by the weight of an equal volume of water. It has no units, just like density. And it's important because if you need to achieve a certain mass, let's say your prescription that you need a compound calls for 60 grams of a compound, and you're using a liquid ingredient to compound a solid, then you need to know the mass of the liquid ingredient, because you can't add up grams with milliliters to give you the 60 grams. That doesn't work out unit-wise. So to get you from grams adding to milliliters to get the 60 grams, 2 grams plus grams to give you 60 grams, then you need to use a specific gravity where you can convert the milliliters of that substance to grams using this important equivalency. I say it's important equivalency because we're going to use it throughout the 3 examples. So memorize this equivalency where the specific gravity is equivalent to the weight of a substance divided by the volume of the substance. So basically we converted this formula, weight of the substance divided by weight of the equal volume of water, to this formula, weight of the substance divided by volume of substance, where the weight of the volume of water was changed to the volume of the substance. So they're pretty much equivalent. They actually are equivalent. So if you memorize just this formula, the weight divided by volume, you should be fine in terms of topical calculations. And a helpful hint, if it helps you remember, it looks just like the formula for density. If you remember from grade school or high school, where density is equivalent to mass over volume, here specific gravity is also equivalent to mass over volume. So if you know 2 values, you can calculate the third value by using this equivalency or using a ratio with this equivalency. So basically, if you know the specific gravity and the volume of a substance, you can determine the weight of a substance, especially for a liquid ingredient. So to illustrate this, the 2 methods of determining the mass, here's an example. So vanilla extract has a specific gravity of 1.78. You used 4 milliliters of vanilla extract to compound an oral gel. How much did you use in grams? So if we're trying to achieve a certain volume or a certain mass, such as 10 grams of a topical product, and we use a liquid component, vanilla extract, we can't use the volume to determine how much we need to get to the specific mass of the topical product. So we need to convert this milliliter to grams to make sure we get to that certain grams of the topical product. So we know the specific gravity formula is a weight of a substance divided by volume of a substance. So there's 2 ways of doing it. We can do method number 1, which is setting up the formula. We know that specific gravity is 1.78. We know the weight is unknown, x grams, and we know the volume of the substance is 4 milliliters. So multiplying 1.78 by 4 to solve for x gives you 7.12 grams equals x. Another way is setting up like a ratio. So we know that 1.78 grams per 1 milliliter, which is based off this formula. 1.78 for specific gravity. 1.78 grams is on top, then 1 milliliter is on bottom because the volume of the substance is on the bottom. So 1.78 divided by 1, which also gives you 1.78. And you know you had 4 milliliters solving for, and x goes on top. So notice how the units match up. So grams is on top and milliliters is on bottom. And the specific gravity is on the left and the unknown is on the right. Solving for x also gives you 7.12 grams. So there's two ways. They're basically equivalent. They are equivalent, and they both use the same formula, just in different ways. One is on top, which is using the straight formula. And number two, one is using the specific gravity and thinking of it as a ratio, where you have grams on top, milliliters on the bottom. So the specific gravity, 1.78, is the weight of the substance, grams divided by the 1 milliliter, since milliliters is on the bottom. And then setting it the ratio like that. Either way, it gets you the same answer. So to illustrate the concepts in topical calculations, I'll go through 3 different calculation problems. Number 1, we have a script for triamcinolone, 0.025% ointment. We're gonna make 30 grams. The SIG is to apply to the leg 4 times a day as needed for itching. The stock recipe calls for triamcinolone 1% ointment, making up to 10 grams. It's going to use triamcinolone 1%, mineral oil as needed or as necessary for wetting, and aqua base and urea, which are the bases, QSAA, meaning of each. So we're going to have equal parts of aqua base and urea, which is the base. So the active ingredient is triamcinolone, the wetting agent is mineral oil, and the bases are aqua base and urea. And we're going to have equal parts of the aqua base and urea. So we know that the specific gravity of mineral oil is 0.88. While wetting the ointment for the prescription, 2.5 milliliters of mineral oil was used to wet the triamcinolone powder and incorporate it into the ointment. We're going to calculate the weight of each ingredient necessary to complete the prescription. So if you haven't seen a topical product before or haven't seen one made, think of it just like making brownie mix out of a brownie box recipe. So the active ingredient would be the triamcinolone, which is basically the brownie. Triamcinolone, which is equivalent to the brownie powder. Then we're gonna wet it with mineral oil, or in the brownie analogy, it's going to be water. So the wetting agent helps to get the brownie into a more solid product to put into the oven for baking. So basically the wetting agent, in here mineral oil, helps to wet the triamcinolone powder to help it get into a more solid product as a cream or an ointment. Just like water in a brownie recipe adds to brownie powder to help it form a more solid component for eating later. And the bases, aqua base and urea, are there to help, number 1, add more weight to the substance, and number 2, to help dissolve the rest of the product, help it form into a more suitable ointment or powder, or ointment or cream. So given that the specific gravity of mineral oil is 0.88, and we're gonna wet the prescription with 2.5 milliliters of mineral oil to help incorporate it or make it into a better solid ointment or cream, we're going to calculate the weight of each ingredient necessary to complete the prescription. So step number 1, we're going to calculate the total mass of the product needed to complete the prescription. As I said before, we know that for solid products, we have to calculate for 10% extra mass of the topical product to account for loss, including loss of powder or powder dissolving away and you don't find it anymore. So step number 1, we're going to calculate the total mass of the product needed to complete the prescription. We know that we're going to make 30 grams of ointment. So step 1, you can do it 2 ways. 30 grams plus 10% of 30 gives you 33 grams. You can do it another way where 30 times 1.1, where 1.1 accounts for the 100% plus the 10%, gives you 33 grams. So we're gonna need a total 33 grams of product. Step number 2, we're gonna calculate the mass of the active ingredient needed to compound the prescription. So we know that the ingredient is, or the active ingredient is 0.025%. And for solid products, that usually means weight by weight. So 0.025% is equivalent to 0.025 grams of AI per 100 grams total. So 25 grams of AI, 100 grams total. We know that we need to make 30 grams total, 33 grams total. So how much is the weight of the AI? I put the 33 grams because grams of AI lines up on top, lines up with grams of AI on top, and grams total on the bottom lines up with grams total on the bottom. So solving for x, so 0.025 divided by 100 times 33 gives you x equals 0.00825 grams of active ingredient. So we found the mass of the active ingredient needed. Step number 3, using the specific gravity and the volume of the wetting agent used for the prescription, we're going to calculate the mass of the wetting agent used for the prescription. So we know here specific gravity of mineral oil is 0.88, and know we used for the prescription 2.5 milliliters of mineral oil. So remember that specific gravity is equivalent to the weight of the substance divided by the volume. So we know the specific gravity was 0.88. I'll do it both ways. So one way is 0.88. We don't know the mass, x grams. We know we use 2.5 milliliters. Solving for x gives you 0.88 times 2.5 gives you 2.2 grams of mineral oil, MO. The other way is setting it as a ratio. So we know that 0.88 grams divided by 1 milliliter. We know the milliliter should go on bottom to match unit placement. Solving for x grams. X gives you 0.88 times 2.5 again, gives you 2.2 grams. Let me fix that. So, step 4. Knowing the mass of the total product, the active ingredient, and the wetting agent, we know the mass. We need to determine the mass of the bases used to compound the prescription. So, in math form, we know the total mass is equivalent to Triamcinolone, mineral oil, aqua base, and urea. So, writing that out, I'll put T for Triamcinolone, MO for mineral oil, plus aqua base, plus urea. We know the total mass from here is 33 grams. We know the Triamcinolone mass was 0.00825, and the mass of mineral oil was 2.2 grams. Plus aqua base plus urea. So we know that the recipe calls for aqua base and urea, QSAA for both of them, meaning equal parts of each. As I said earlier in the concept, QSAA. You know the theme song? QSAA means of each, meaning that equal portions of each ingredient must be calculated. So 33, we'll simplify this. So 33 minus 0.00825 minus 2.2 gives you 30.79 grams equals A plus U. And we know QSAA means of each. So we have two ingredients. So these are pretty much going to be the same. So 30.79 grams equals 2x divided by, so 30.79 divided by 2 gives you 15.4 grams of each base. So that means 15.4 grams of aqua base and 15.4 grams of urea. Another way of thinking of it is, if you know the total mass was 33 grams, you know you had Triamcinolone, which is 0.00825 grams. You know you had mineral oil, which is 2.2 grams. Simplifying that also gives you 30.79 grams. You know you had two ingredients, or two bases. So 30.79 divided by 2 for each base gives you 15.4 grams of each base. Another important concept that this illustrates is the concept of specific gravity. So if you had the volume of mineral oil, which is 2.5 milliliters, you can't add grams and milliliters together to get the total mass. So that's why I use a specific gravity to convert milliliters to grams using the specific gravity formula. And that's why you can now add grams to grams to grams to get your 33 grams. And to check, if you check on your own, you know that the 33 grams is given or is added up by the 0.00825. Add this up yourself, plus 2.2. I'll add it right here. 0.00825 grams plus the 2.2 grams of mineral oil plus the 15.4 grams of aqua base plus 15.4 grams of urea gives you 33 grams, which is what we needed. So we did solve for each component, 15.4 grams of each base and 0.00825 grams of AI plus 2.2 grams of mineral oil. Next prescription calls for Doxepin 5% cream. It's used for pruritus or itching. We're gonna make 25 grams. Stock recipe calls for Doxepin 10% cream, making 10 grams. Using Doxepin 1 gram powder, glycerin 5 milliliter wetting agent in the stock recipe, and hydrophilic ointment QSAA. Given that the specific gravity of glycerin is 1.25, calculate the weight of each ingredient necessary to complete the prescription. So again, number one, we're going to calculate the total mass of the product needed to complete the prescription. So we know the prescription calls for 25 grams. So step 1, 25 grams plus 25 times 10%, or you can do 25 times 1.1, gives you 27.5 grams total needed. Step 2, we're going to calculate the mass of the active ingredient needed to compound the prescription. So we know Doxepin this prescription calls for Doxepin 5% cream, meaning that it's 5 grams of AI over 100 grams total. So 5 grams of AI per 100 grams total. We know we're working at 27.5 grams total. How much Doxepin do we need? So solving for X gives you 1.375 grams of Doxepin needed to compound the prescription. So step 3, using the specific gravity and the volume of the wetting agent used for the prescription, calculate the mass of the wetting agent used for the prescription. However, we don't know how much wetting agent was used for the prescription, but we do know the mass of the wetting agent, or the volume of the wetting agent used for the stock recipe. Going back to the brownie recipe analogy, if we know that the stock, the one in the blocks, calls for a quarter cup of water for 1 full box. But let's say we don't want to eat the full box. Let's say we're gonna make half the box. So for half the box of brownie powder, how much? So for half the box of brownie powder, how much water do we need for this new recipe, for our new prescription? So we're going from the stock to the prescription. We know how much wetting agent we needed for the stock, but how much are we going to use for the prescription? Especially since we're using a different strength. So stock calls for 10% Doxepin. However, we're going to make 5% Doxepin. So how much are we going to use? So to do that, we're going to base it on the active ingredient. So as step 3 says, the volume of the wetting agent is known for the stock recipe, but not for the prescription. So the volume of the wetting agent for the prescription must be calculated first. So as I said in the important concept, sorry for the scrolling, calculations for the wetting agent must be based on the weight of the active ingredient in the stock recipe, since this is being used to help incorporate. Remember that 20 drops is 1 milliliter for future reference. So you can set up a ratio. So if we know that, how much should we use for the wetting agent? So 5 milliliters of wetting agent per 1 gram of Doxepin in the stock recipe. So 1 gram of Doxepin calls for 5 milliliters in the stock recipe. We know we're going to use 1.375 grams of Doxepin. So grams is on top to solve for milliliters on bottom. How much wetting agent do you need to use for 1.375 grams of Doxepin? So solving for X, you're gonna need 6.875 milliliters of wetting agent for this new prescription. Now, Since we know the specific gravity and we know the milliliters used for the prescription, which is 6.875, we can calculate the mass of the wetting agent used for the prescription. So step 3B, given the specific gravity and the volume of the wetting agent used for the prescription, the mass of the wetting agent used for the prescription can be calculated. So we know the specific gravity is 1.25, and we know for the prescription, we're going to use 6.875 wetting agent for the RX. So there's, again, 2 ways of doing it. I'll show you both ways. There's the formula way, 1.25 equals X grams over 6.875 milliliters. Solving for X, so 6.875 times 1.25 gives you 8.59 grams. Or the ratio way, 1.25 grams of over 1 milliliter. Matching up units, so grams is on top, milliliters on bottom. 875 milliliters. Multiplying by 6.875 again. To solve for X gives you 8.59 grams equals X. So now, number 4, we know the mass of the total product, the active ingredient, and the wetting agent. We can determine the mass of the base. So the only base here is hydrophilic ointment, and it's QSAA. So we need equal parts, basically one of each of hydrophilic ointment. So we know, step 4, the total mass is 27.5 grams. We know the mass of triamcinolone was 1.375 grams. Or not triamcinolone, Doxepin, sorry, Doxepin. We know the mass of the wetting agent was 8.59 grams, which is the wetting agent. And what's the mass of the base? So 27.5 minus 1.375 minus 8.59 gives you 17.5 grams of base. And we didn't have to divide by 2 because we only have one base. So if you only have one base, just keep it the same. 2 bases divided by 2, 3 bases, QSAA divided by 3, so on and so forth. And finally, the last prescription, Tacrolimus, 0.1% ointment. We're going to make 70 grams. Say gets apply as directed for vitiligo. If you don't know what vitiligo is, it's an interesting skin condition. Tacrolimus is an immunomodulatory agent used for a lot of conditions, primarily for solid organ transplants like liver or heart transplants to prevent kidney rejection by the host, or to prevent rejection in general by the host. However, in skin conditions, a lot of skin conditions are have immune causes. So tacrolimus is an immunomodulating agent used for a lot of skin conditions. And if you want to look at vitiligo, check out images on Google. It's pretty interesting. So the stock recipe calls for tacrolimus 5% ointment to make 20 grams. It calls for tacrolimus 1 gram mineral oil, 30 drops QS wetting, and petrolatum as the base, QS to 20 grams. Given that the specific gravity of mineral oil is 0.88, calculate the weight of each ingredient necessary to complete the prescription. So again, for number 1, calculate the total mass of product needed to complete the prescription. So we know that the total mass of the product should be 70 grams for the prescription. So 70 grams plus 10% of 70, or you could do 70 times 1.1. Either way, it gives you 77 grams. So we need to make 77 grams total And now step number 2, we're going to calculate the mass of the active ingredient needed to compound the prescription. So we know the strength of Tacrolimus is 0.1%. So step 2, 0.1% is equivalent to 0.1 grams of AI over 100 grams total. We know we're working with 77 grams total. Solving for x. X gives you 0.1 divided by 100 times 77. 0.077 grams of AI. Step number 3, using the specific gravity and the weight and the volume of the wetting agent used for the prescription, calculate the mass of the wetting agent used for the prescription. So we know how much is mineral oil used for the stock solution or stock recipe, which is 30 drops, but we don't know how much we use for the RX. Just like the brownie recipe, if the stock brownie, the full box calls for a quarter cup of water to incorporate the powder, how much water are we going to need for half the box to incorporate the powder? So we know the stock recipe calls for 30 drops. How much are we going to need for the prescription, which is different from the stock recipe? So we know that 30 drops was used for 1 gram of Tacrolimus. So 30 drops of wetting agent was used for 1 gram of AI. We don't know how many drops are needed for the prescription, but we know the prescription calls for 0.077 grams of AI. Solving for x gives you 2.31 drops. And we know we can't give 2.31 drops with a pipette, so rounding up, we give 3 whole drops, because you can't measure partial drops with a pipette. You can either give 1 whole drop or no drops. So now we know how many drops we use for the wetting agent. How much is that in milliliters? So remember that 20, as I said earlier, 20 drops is equivalent to 1 milliliter. So 20 drops per 1 milliliter. We know we use 3 drops. And solving for x gives, or x milliliters. Solving for x, so 3 divided by 20 is 0.15 milliliters of mineral oil. So now we have the amount of mineral oil needed for the prescription. Not just for the stock recipe, but we know how much mineral oil we need for the specific prescription. So now we can use the specific gravity. Step 3b, given the specific gravity and the volume of the wetting agent used for the prescription, the mass of the wetting agent for the prescription can be calculated. So you know the specific gravity mineral oil is 0.88. So I'll do it both ways again. So 0.88 equals x grams divided by 0.15 milliliters. Solving for x gives you 0.132 grams of mineral oil. Or the other way, 0.88 grams per 1 milliliter equals x grams over 0.15 milliliters. Solving for x also gives you 0.132 grams of mineral oil. So step 5, since we know the total mass, the mass of the active ingredient, Tacrolimus, and the mass of mineral oil, how much petrolatum do we need now? Since its QS to 20 grams. So let's see, 5. Where's up? Did I get my steps wrong? 1, 2, 3. Oh, no, this shouldn't have been step 4. Sorry, it was also part of step 3. So now this is step 4. Calculate the total, or the mass and the base needed. So we know we need 77 grams total. You know, the mass of Tacrolimus was 0.077 grams. Tacrolimus. We know the mass of the wetting agent was 0.132 grams of mineral oil. How much base do we need? So 77 minus 0.077 minus 0.132. So that gives you 76.791 grams. 91 grams of base. So petrolatum, we're going to need 76.791 grams. Check our math. We know 76.791 grams plus 0.132 plus 0.077. And that gives you exactly 77 grams total, which matches what we needed total. Which also matches what we needed total. And notice how, as I said earlier, in the important concept, sorry for all the scrolling, that the total mass needed is different from the mass dispensed. So an example, number 1, the total mass needed was 33 grams, but we need to dispense 30. That's because we're making extra. So just weigh out the 30 grams, put it in the ointment jar, and then dispense the 30 grams to the patient. Weigh out the 30 grams, put it in the ointment jar, and dispense it to the patient. Here, we needed a total mass of 77 to account for extra, but we only needed to dispense 70. So weigh out the 70 grams, put it in the ointment jar, dispense to the patient. So, just to go over the concepts again, make sure you make 10% extra first, especially for solid products. QSAA means equal portions of each ingredient, meaning equal portions of base. So if you have 2 bases, divide by 2 when you calculate how much base is needed, total base is needed. If you have 3 bases needed, divide by 3 when you calculate the amount of total base needed. The active ingredient must be used in calculation for the wetting agent if you're going to figure out how much wetting agent is used for the prescription. Remember that 20 drops is equivalent to 1 milliliter. Specific gravity, memorize the formula. Weight of the substance divided by volume of the substance. And if you have 2 values, you can calculate the third value by using 2 ways. Either way gives you the same answer. So that's it for the calculation video. And good luck with your exam. And good luck with making topical prescriptions.